This is the second video and final video for section 7.2. So we've been talking about composite functions, and right now we're talking about the composition of functions when the two trig functions are different. But I want to draw your attention to this blue box down here in the right corner. So if the value in the arc is on the unit circle, then you can just work through our problem from the inside out. So if you look at 3a, if we had the cosine inverse of root 2 over 2, well, we know the value of that arc. We can find that on the unit circle, and then we can take that angle measurement and plug it into tangent and get our answer. But the examples that I'm going to be doing are a little trickier, and they're examples in which the value isn't on the unit circle. Okay, so we're talking about the composition of functions when the arc is on the inside and your value isn't on the unit circle. So I'm going to do example 3a while I'm going through these blue directions up here, just to kind of lay out the process a little more. So the first step up here, it says determine what quadrant you're working in. And this is based on the inside function. It will help determine what is positive and what is negative. All right, so when we're talking about cosine in reference to its inverse, we need to remember that we restricted the domain of cosine to 0 to pi, right? Because our inverse, in order to have an inverse, it needed to be a one-to-one function. So in order to do that, we restricted the domain. So it's asking us what quadrant we're working in. Well, if I draw my unit circle, let's pretend that axis is, kind of straight. Then I'm looking from 0 to pi, which means I'm only concerned with values in quadrants 1 and 2, right? But now I need to figure out what is positive and what is negative. And so that means that I'm looking at the value inside my arc. So I'm looking at negative 1/3. This means that I need somewhere where cosine is going to be negative, because that's a negative value in here. And in this case, if you think to your all stupid trig crap, cosine is negative in the second quadrant, right? So I've done step 1. In this case, I'm working in the second quadrant because of the negative I have over here. Now what we're going to do is construct a triangle in that quadrant. So I'm going to do exactly what that says, and I'm going to draw a triangle. Let's pretend it's a nice looking triangle in the second quadrant. So down here I have my angle measurement theta. And so now in order to label the sides, I'm talking about cosine here. So think back to like SOHCAHTOA. Cosine is the adjacent over hypotenuse. So then that means that my hypotenuse is the 3, and the adjacent side is technically negative 1, but we're going to ignore the negative for now because we're talking in reference to the side length of a triangle. So for now, we're just going to say the side length is 1, because you can't have a negative side length. And then this last side, we don't yet know what that side is, so I'm just going to label it B. So I've determined what quadrant I'm in. I've constructed my triangle. Now I'm going to use the Pythagorean theorem to find the missing side of that triangle. So I have 1 squared plus b squared equals 3 squared, which gives me that b squared equals, 8, right? So b equals the square root of 8, which also equals 2 root 2, because it's square root of 2 times the square root of 4. Square root of 4 is 2, so you can break that down. So then that means I'm going to redraw my triangle down here. This is my angle measurement. So I have this side is 1, this is 3, and up here we have 2 root 2. So what we just did, we used the arc, and this arc in here tells us how to build the triangle that we need. But now this outside function is going to tell us what values to pick off of our triangle to find the answer. So we're going, and that's what step 4 says. Pick off the numbers you want based on the outside function. So that means I'm talking about tangent, right? And so we're thinking again with SOHCAHTOA. So tangent is opposite over adjacent, right? So all I'm doing now is I'm saying, okay, well, if I want tangent, then my tangent equals the opposite side over my adjacent side. So I have 2 root 2 over 1. So the tangent equals 2 root 2. So that is almost my answer, right? So I build my triangle, I pick values off, and I use SOHCAHTOA to figure out what this tangent is going to be. So, and you can check me, put 3a straight into your calculator, and if you also put 2 root 2 in your calculator and get the decimal, it'll be the same. But we need to think back to the fact that we had a negative in our original problem, right? But we just ignored the negative because of the side. So now we need to think back again to our all stupid trig crap to figure out if our answer should be positive or negative. Well, we have all stupid trig crap. So the only thing positive, we're looking in the second quadrant still. The only thing positive is sine, which means that our answer is actually negative 2 root 2. Okay? So this in and of itself is our answer. All right? So let's try one more example. I know this is probably super confusing. Don't feel bad. It was confusing to me too. Right? So we're going to look over here. I'm going to change the color just to make this different. All right. So our first step is to figure out what quadrant we're working in. So I'm talking about tangent. And when we talk about tangent, we're actually talking about the domain being from negative pi over 2 to pi over 2. Okay, again, we needed to restrict our domain. That was from section 7.1. So we're looking from negative pi over 2 to pi over 2. And we know that negative pi over 2 is the same as 3 pi over 2. So our answer is going to come from either the first or the fourth quadrants. The value inside my arctan is positive. And if you think to all stupid trig crap, we're only going to have a positive tangent in the first quadrant when, if it's the first quadrant or the fourth quadrant, tangent is going to be positive in the first quadrant. So we've done step 1. We figured out what quadrant we're working in. Now we're going to draw our triangle. We have our angle theta. And so I have tangent of 1 over 2. So again, I've got my SOHCAHTOA. So I have the opposite over adjacent. So my opposite side is 1. My adjacent side is 2. So now we use this. We do step 3. We use the Pythagorean theorem to figure out what the hypotenuse is. So I'm doing 1 squared plus 2 squared equals c squared. So I'm left with 1 plus 4 equals c squared. Square root of 5 equals c. So up here I have square root of 5. Right? So I built my triangle. Now I'm talking about sine now. I've moved away from the tangent and the arc sine, right? Now I'm just going back to simple geometry things, and I'm talking about sine. So sine is the SO part of SOHCAHTOA. So I'm looking at the opposite over the hypotenuse, which means I'm looking at 1 over the square root of 5. So now ask yourselves, well, is my answer going to be positive or negative? I didn't have any negatives to ignore in the first place, so my answer for this problem is actually 1 over the square root of 5. Right? I know this seems complicated. We'll do more work on this in class. But you just need to build your triangle, look at the outside trig function, figure out, the opposite over adjacent, adjacent over hypotenuse, that kind of thing, and just use what you know from geometry. There's not a whole terrible lot of pre-calc going on in a couple of these steps, okay? So your quizzle for this video, you only have one question, and that is to find the exact values of both A and B. I'll give you a little hint. One of them is something you can find on the unit circle, so you don't have to go through all that hassle that we did on the first two examples, and one of them you will have to go through all that hassle. All right, so come in tomorrow with questions and let me know.